Thank you. All right, so I've got a bit of a challenge. I've been asked to present you 3 projects in 10 minutes, so it's very likely I'll go over time, but I'll try not to. So pretty much, yeah, I'm going to talk to you about 3 projects which are all a bit special and of interest because they are all actually trials that we do here in Victoria with 3 different water utilities. So the first project I'm going to talk to you about is the Waternomics one. We have Western Water. The second one is the Swanboard trial we do with Codependent Water. And the last one is about satellites, and guess what? It's with Goulburn Marine Water. So the first one, Waternomics, is really in the context of helping the water utilities better manage their network. So lots of you are in water utilities, so you know that when there is a major event, let's say a big burst or a big water shut-off, operations at the water utility can be very stressful. For example, usually what happens is as soon as you've got a big burst, it impacts customers, and usually the first thing customers do is that they call the customer contact center. That results in a very high amount of calls, and actually the stress level on the operators to quickly address the issue increases. In this context, the operators can be under a high level of stress because first of all, they need to understand what's happening. And this requires for them to have a look at a whole lot of different data sources. They want to have information on the pipe, so they have to look at their GIS. They also have a look at their different sensors, if they have any, so through SCADA. They also want to know who's around, and if they have any GPS tracking devices, they also want to actually know who's the closest to the pipe so that that interruption could be as short as possible. Doing that at the moment can be a bit challenging because all of these data elements are in all different data sources and data systems, which are in practice, well, very often not very practical to use. And in these situations, a quick data access is actually critical and can be actually the key to avoid a major burst or something that's going to make all your customers very unhappy with you. So in this context, what we've designed is a solution called Waternomics, which is pretty much just a system that aggregates all of these data sources together in the same system. So just for you to have a glimpse at it, so this is what Waternomics look like. I wasn't allowed to give you a proper demonstration, but yeah, pretty much it's like Google Maps with pipes and other stuff. So for example here, operators can see the water pipes in blue and some information about the work orders and also about customers' information. So here, it's really to help the operation center to see in real time what's going on the network. So Waternomics was initially really about trying to visualize way better information, real-time info, but obviously when you're a data scientist and when you see all of that data coming at the same place, building some analytics is actually very tempting. So very recently, what we've done is that we've got a couple of data scientists working on some applications, and we thought, well, wait, we have all of that data coming from different systems, all in the same platform. Well, there may be actually some value we can get from this. And we worked on different applications, and we recently focused on one, which is the prediction of sewer blockages. If you ask any operator, for example at Western Water, about if that pipe is likely to experience any sewer blockage, usually experienced people will tell you, yeah, actually this pipe has a pretty small diameter and it's been also changed 20 years ago. And it's going to get this intuition to say that actually some pipes are going to be more critical than other pipes. Well, the machine learning is actually a big word to say that it's just a statistical model that replicates this kind of intuition, and the calibration of this type of models is based on historical data. So you pretty much try to reproduce the thinking of experienced operators. And from this, so what we managed to do is actually predicting the sewer pipes which are the most likely to be blocked in the coming 6 months. So at the moment this is very exploratory, but as this is part of the trial with Western Water, we're in the process of validating all of this, and results so far have been very positive, meaning that the next logical step is to have actually these algorithms directly in Waternomics, so that users can be informed in real time of what next sewer pipe is going to be blocked. So high-level summary of this project. Sorry, I can't tell you more. So obviously, we're doing this with Western Water. The IWN is actually the major source of funding, and as Andrea was telling a few minutes ago, as such, obviously, so we're writing at the moment a report with all of the lessons learned of this, and so I really invite you to keep an eye on this because trial is about to end in a month, so report is going to be released very soon. All right, let's move to the second project, which is the Swan Bowl trial. We do this with Codependent Water. So the Swan Bowl trial is just a kind of actually simple device. So it's a device that was designed to measure water quality in remote reservoirs. So it's just basically a set of probes that can measure different parameters. And the device is also equipped with a communication module and an energy producing module, meaning that everything was designed so that you just put the buoy in the reservoir and you can simply forget about it. So the question that we had is, well, this device is awesome, but what do you actually do with the data? And so we asked Codependent Water to see if we could investigate this with them. And we installed one of these buoys in one of the reservoirs. So the most knowledgeable of you will have recognized the Malmesbury Reservoir. So pretty much why the Malmesbury Reservoir? That reservoir is of high interest for us because Veolia operates 2 water treatment plants downstream of this reservoir. The idea being is if you can know in advance the water quality that's going to reach, of the water that's going to reach your water treatment plant, how can you use this information to optimize the water treatment at your plants? And this is exactly what we're trying to do. So usually when the water quality is bad in the Malmesbury Reservoir, we know that between 12 hours or to 24 hours after this, the water at the plant is going to be of poor quality, and the whole objective of the trial is to see how we can optimize the treatment at these 2 treatment plants to, for example, save chemicals and make things a bit more efficient. Speaking about water quality, so one thing we measure is obviously the water turbidity, electroconductivity, which are per se good indicators of the water quality, but not only. The other thing we measure is actually the oxygen concentration. And the oxygen concentration is actually a great indicator of blue-green algae in the water. So for example here, this is data from France, and I'm sorry there is no x-axis, but this is time. What you can see here is the dissolved oxygen concentration profile measured in a reservoir contaminated by algae. The fluctuations that you can see are diurnal fluctuations, simply because when you've got algae in the water, as soon as the sun comes up, they do the photosynthesis, and then they produce oxygen. So the concentration of oxygen increases, and then at night it's the contrary that happens. Based on this, you can see that here, after let's say 10 days, you have those fluctuations of high magnitude, and that gives you a bit of an insight. It tells you that you probably have algae in your reservoir. What we've done, we've partnered with Massey University in New Zealand, and they actually built a mathematical model to translate the magnitude of these fluctuations into a proper algal concentration. So we've spent the last 6 months doing this model, and now it's time to validate it. Yeah, 1 minute. Yeah.